Now I know that looks awful, okay? But really, these are all just constants mainly, right? It's just that y, that single value that I'm after, okay? Now I'm going to use this when I get the area of PQRS, and I'm just going to have one variable in that equation, okay? So keep that in mind. Maybe sort of put something around it so that in all of your lines of working it doesn't get lost. Now I'm going to get the area of PQRS. I'm going to move this out of the way so that I can have a second column. Okay, now PQRS, just a rectangle, right? And I said it had dimensions x by y. X by y, I know what x is in terms of y, right? There's my x, okay? So x by y will become this times 2a on h, 1 minus y over h. It's worth noting, if you like, from this equation here, you could have eliminated y instead and have this equation in terms of x's. It doesn't matter. You're going to end up with an equivalent equation. Okay? Now, let's see here. After you simplify this, you're going to end up with, 2a on h squared outside of h y minus y squared. That's just eliminating this fraction and getting the y in there. And you can see it's a quadratic. Okay? Don't forget this 2a on h squared. Looks terrible, but it's just a constant. I've got to keep reminding you of that, because when you get a question like this, it's very intimidating. You're like, have I done it right? Have I done it wrong? It's all fine so far. Okay? Now that I've got this area in terms of one variable, as usual with maximum questions, I differentiate. Okay? So the derivative of that area with respect to y, because that's the variable over here, okay, is going to be equal to, and because that's a constant out the front, like if it was down to 5 and you were differentiating this, you would ignore that 5 and just go after this part, right? You just stick it out the front, and then x minus x squared turns into minus 2x. Yeah, that's how you differentiate. Well, this is also a constant out the front, so just ignore it. Stick it there and then forget that it's there. Look at these parts, which are the real bits we're interested in differentiating. So the derivative of hy, y is the variable, h is the constant. So it's just h, okay, minus 2y. Is that okay? All right, now, to find our maximum area, right, I'm going to need a stationary point here. Well, stationary points exist when that derivative is 0. Okay, I'm just trying to be quick so that I don't have to write this whole thing. And you can see there's only one solution to this, right? This part out the front, it's a constant, doesn't matter. So h minus 2y, that part's got to be equal to 0, right? So you move your 2y over, you get 2y is equal to h, y equals h on 2. Now remember what we're trying to prove, right? We're after this area being half that area. So this is a very promising sign, because it looks like our numbers are headed in the right direction, okay? There's a stationary point, but to know that it's a maximum, you've actually got to show that, okay? So looking at this first derivative, do you think it would be easier to test it's a maximum by first derivative on either side, or by using the second derivative? First or second derivative? I think second. Because when you look at this, even though it looks awful, all of these are constants. So when I differentiate, they're just going to vanish. It's actually just a linear function. Okay? So if I differentiate again, second derivative of this area function with respect to y again, okay, this part's going to disappear. I'm just going to end up with this, which is minus 2. 2a h squared minus 2. Okay? So this is minus 4a on h squared. Now you look at that and you're like, hold on. At this point, we're used to finding a number of some kind, okay, like minus 3 or 12 or something like that. This doesn't look like a number, but it is, because a is just a constant and so is h. But you need to know, why do we go, what result were we wanting out of the second derivative? We want concavity, right? We hope that this is a max, okay? So we're expecting this to be concave down, right? So we're expecting this to be negative. Is it negative?
Yeah.
It is negative because a is greater than 0, right? It's an area. And h is greater than 0 because it's a length, right? Therefore, this is negative. Okay? Now, that's crucially important to make that, okay? There's a classic question, again, it's out of this exercise, it's talking about the strength of a wooden log, and it has to, you end up with, when you differentiate, you get something like this, and it's got letters in it. You can't just say, oh, it's negative, because the question promised it would be negative, okay? You've got to say why, that you've got a minus sign at the front, and these other bits are positive, okay? So this is crucially important. Therefore, concave down, maximum, okay? Now, the endpoints here are kind of trivial because if you take y to its minimum, it's going to be 0, so no area. If you take y to its maximum, it'll be equal to the perpendicular height. Again, it'll be 0. So this is the height that I'm after. This is the absolute max. Now, height is related to the area that I'm interested in. Okay? So you bring it back to your area function. Okay? The area of PQRS, that rectangle, okay? It works out to be, here's my, let's see here. Here's my area function, okay? 2a on h squared outside of h squared on 2 minus h squared on 4. Now check out, you see where my substitution has gone into here, okay? And what you've got here, 2a on h squared times let's see here. H squared on 4, right? A half minus a quarter, it's just a quarter. H squared cancels, 2 cancels, leaving you with a 2 on the bottom, and it's half the area, as we were hoping, okay? So, when someone holds your hand through it, you're like, oh, that's not so hard. What's difficult about this question? You've got to start off with all of these unknowns, and there are no numbers to help you out, okay? Then you've got to find a relationship so that you can eliminate one of these. You can only have one variable so that you can differentiate. Okay? The rest of it, I think you guys know how to do. Yep.
Would we get like walked through it in the exam?
Would you get walked through it in the exam? It depends what section of the exam this question is. Okay? So if it was the last section, right? Question 4, part E or whatever, I think it would be, you've got sort of like a 50-50 chance that they might guide you through, say, showing this similarity, right? And then go for it. Or they might just dump you in the deep end, okay? If it was, say, an earlier section, you know, question 2 instead of question 4, they'll probably have a few more steps there, okay? But they're expecting you, the later it comes in the exam, they're expecting you to work out more of it on your own. Does that make sense?